Hey everybody, it's Mr. N here, and we are doing the next section. This one is on derivatives of trig functions, which is 3, 4 in the 6th edition and 3, 3 in the 9th edition. So before we start, I want to examine the graphs of sine and cosine and recall how they are sketched. This website is awesome. It really helps visualize what's going on. Let me see if I can import over here, and I tried to, but let's see if this works. And this is what I wanted to try to show you guys here. And take a look. As this over here, and I'm looking right here. Notice here's a circle. As I graph, as it moves along the circle, I'm graphing the points that it corresponds to. And let's play that. And that's what you're going to get right there. Okay? You will get this function, which is a sine curve. All right? So now let's go back to, so that's how we graph sine, and cosine is in the similar manner. So it's all based on our unit circle. And what I want to do now is I want to take the derivatives of these. So we're trying to find out what is the derivative of the sine. So we are trying to find, f prime of sine x, okay? And we need to determine what that becomes. All right, so let's take a look here. What we're going to do is we're going to find horizontal tangents. How we always do these problems first. So find horizontal tangents. I find the horizontal tangent, that's right here. I find a horizontal tangent, that's right there. Now, on this one, we start at 0 with a slope that's pretty high. In fact, this slope is going to be 1. Okay? And the slope continues right here. Take a look. The slope continues to decrease until you get to 0. So the slope decreases until we get to 0. And then the slope right here becomes negative, so we're going to be below the axes. So the slope reaches 0, then it's below the axes, and it reaches a maximum about here, and this, I will tell you, if you calculate it out, it's going to be -1. And then the slope just goes back, decreasing in negativity back to 0, right here, horizontal. So it's going to go like this because this is going back to a flat 0 slope, and then it increases positive again. And it repeats the cycle. So this ends up coming down here, going back up through here, and continuing on repeating the cycle. Well, look what you just did. This is a cosine graph right here. So you graphed the derivative. So the derivative of f of x is just cosine x. And guess what happens when you graph the derivative of the cosine? You're not going to get sine x. Instead, you'll get negative sine x, because remember, because right here we're starting in a negative value, so it starts at a horizontal tangent right there, so at 0, and it goes in a negative manner, and these are the zeros right there, with these being my maximums right here. So we're going to come down through here, come up, and back down like that. Okay, so f prime of x, if you have sine x, is cosine. F prime of cosine is going to be negative sine x. So let's take a look at these rules, and all the other ones get developed in the same manner. So the derivative of sine is cosine. Let's go back to the lightsaber here. The derivative of sine is cosine. The derivative of cosine is negative sine. And we've already memorized these limits that I've told you, but it's very helpful to know these for the future. Here are some other derivatives as well. If we take the derivative of tangent, you could do these similar in a graphical manner if you want. If you take the derivative of tangent, you get secant squared. If you take the derivative of cosecant, you get negative cosecant x, cotangent x. And those are the ones I want you to memorize right now. So let's go ahead and put a little cloud around these. These you need to memorize along with those. So memorize. If you really want to see the proofs of them, I think Stewart does prove each of them. It's a little difficult at this point. But the best way you can understand these is through graphical. Just like how I proved to you the derivative of sine is cosine, derivative of cosine is negative sine. To here. All right, so now we're going to do some examples. So let me enlarge this, move this down, and we're going to do some of these examples. All right, for number 1, it says find the derivative of each. So we are going to take the derivative, f prime of x equals, look what I got to do here. I got to do a product rule. So this is going to be first times the derivative of the second, which is the derivative of sine x, which would be cosine x, plus the second, which is sine x, times the derivative of this guy, which is 1, minus, now the derivative of cosine x is negative sine x, so this ends up being f prime of x equaling x cosine x plus sine x plus another sine x. So we're going to say, squeeze in a 2 right there, 2 sine x. Let's see if I can rewrite that so it doesn't look so messy. So plus 2 sine x. All right, moving on to the second one over here. We're going to need the quotient rule. So f prime of x equals the bottom times the derivative of the top, which will be just 2x, minus the top, which is x squared plus 2, times derivative of the bottom. Derivative of the bottom, this part goes away, right? And then you end up with derivative of sine x, which is cosine x, all over this bottom, which is 1 plus the sine x squared. And I'm going to tell you to go ahead and leave it like this because nothing will reduce out. So if you try to FOIL it out, not much is going to happen. All right, now we got to find the slope of the tangent line of this graph at this point. Okay, which means we need to take a derivative here. Now, this derivative is going to be kind of crazy, so let's take a look at what we got. We're going to end up with f prime of x being, okay, we're going to have to use product rule here. So first, times the derivative of the second, which is going to be secant squared x. All right, that's the derivative of tangent, plus that second one, which is tangent x, times derivative of the first. So this is tangent x times my 2x. Plus, now I got to take derivative of cosecant. Derivative of cosecant would be negative cosecant x cotangent x. And I need all of this at pi over 4. At x equals pi over 4. Let's clarify that. Let's write that a little bit better. At x equals pi over 4. So, that means we are plugging in f prime of pi over 4. So I get pi over 4 squared secant pi over 4 squared plus tangent pi over 4 times 2 times pi over 4 minus the cosecant pi over 4 times the cotangent of pi over 4. Okay, doing all these, I end up with pi squared over 16 plus root 2 squared plus pi over 2 times 1 minus root 2 times 1, which ends up equaling pi squared over 8 plus pi over 2 minus root 2. And if you did this on a calculator, you would end up with approximately 1.39. Notice I said on a calculator. I will show you guys in class how to take these derivatives using your calculator, but the trick is on your calculator it has to be at a point. So I will show you that in class. Now, find the equation of the tangent line of the tangent to that. So let's go ahead and do this. Remember, on this one we were just finding the slope. So this gave me my slope, right? The derivative is the slope. Over here we have to find the whole equation of the tangent line. So y prime is going to be cosine x, and we need this at pi over 3. And remember, if I plug in pi over 3, I get the point pi over 3 comma, sine pi over 3, which is root 3 over 2. Right, pi over 3 on our unit circle right there. And this is going to be root 3 over 2 for the sine. So over here, y prime of the cosine of pi over 3 is going to be my slope, and that will be 1/2. Right, we're right here at pi over 3. We have 1/2 comma root 3 over 2. So that'll be 1/2. So y minus root 3 over 2 equals 1/2 x minus pi over 3. That is the equation of my tangent line. The normal, we're going to take the slope, and we want perpendicular, which would be -2. So I end up with the same situation, y minus root 3 over 2 equals -2 x minus pi over 3. All right. So let's take a look at number 6. On number 6, we need to find the limit as t goes to 0 of the tangent t over t. Well, what I want to do here is I want to convert this, and we're going to say that this is the limit as t goes to 0 of the sine of t over t cosine t. And this gives me the following: the limit as t goes to 0 of the sine of t over t times the limit as t goes to 0 of 1 over the cosine of t. Well, we memorize this one. This one is 1. Over here, I get 1 over, if I try direct substitution, I get 1 over 1. So 1 times 1. So this answer is 1. All right, so in class, we'll do a couple more examples, and I will teach you how to do some of these on your calculator. All right, so thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.